Hello
Hello.
there, this is Dr. Dell again, and I am discussing with you the concepts in the Teaching Math book that you now have available on the CD-ROM that you have, where these videos are located too. But this is to supplement what's in the book as you read it, and perhaps you might want to watch these before or after you read the book. And what I'm going to talk today are about some facts and ideas that I think you need to understand in order to really understand what we need to do to solve the problem I discussed in the first video, whereby the modern math high school curriculum is not serving our students adequately and properly. So the first thing that I talk about in chapter 2 is what is called the effective math education triad. Now, I've been teaching mathematics for decades now to students at all levels, and I find that this is pretty much what you've got to do at any level, whether the student is a ranked beginner that's just getting started, which a lot of students will be that take the foundation course, or whether they're adults that are trying to brush up on their mathematics or maybe learn it for the first time. But this math ed triad is what I've discovered is really the key to successful math education, however you do it. And call it a triad because there's three components to it. It's like a three-legged stool. And the three components to the triad are psychology, pedagogy, which means the art of how you teach it, and then the content of what you're teaching. And these three all go together. You cannot have a successful program in math if any one of these is missing. But I'll talk about them separately, and I'm going to start with the most important one, which is the one at the top, which is the psychology. Now, you might say, what has psychology got to do with it? In fact, whose psychology are we even talking about? And of course, the answer is, well, the student psychology. This is very often many students' most serious impediment to learning math. They're afraid of it, or they don't like math, or they've had a bad experience with math. Their psychology is such that it's going to impede them learning math, maybe prohibit them. The first thing that you need to do as a teacher with a student is be sure there's no fear and any other negative attitudes a student might have. And if there is fear, you've got to eliminate it. And in fact, that has to be a successful teacher's first order of business. Now, once you eliminate the negative attitudes and get rid of the fear, then the next step is to begin to create enthusiasm for math and joy for doing math. Because the facts are, you're not going to get good at anything if you don't begin to enjoy doing it and get fulfillment out of it. One of the techniques for this is to embrace mistakes. When you're doing math and learning math, you're going to make a lot of mistakes. That's just par for the course. It's what everybody does. And so embrace these mistakes as evidence of that you're doing something. And these are learning experiences, and you're going to learn from your mistakes. And the more mistakes you make, the more you're going to learn. So all mathematicians, by the way, when they're doing math, learning new math, or doing research math, which means learning new math, are always making mistakes, and you do it all the time. So you want to learn to embrace that and enjoy it. And in fact, I maintain that psychology of your student is the number one job for a math teacher. And if you fail at this, then everything else is just going to be for naught. Now the question is, well, how are you going to get a student psychology right? What if a student doesn't like math? They're afraid of it. They've had a bad experience with it. Well, here's the answer. And there's two components to it. One is pedagogy, the way you teach it, and the second is content. First, I'm going to talk about pedagogy. Then I'm going to talk a lot about content because that is really, really a big point of failure in our modern system. Pedagogy is how you teach. It's sort of the study of teaching. Now, the key to this, in my opinion, is to always be sure that the student is ready for whatever it is you're teaching them. If you're not sure and you're tutoring a student, you want to ask questions and use a Socratic technique where you're always asking questions to be sure the student is following you and is understanding what it is you're teaching them. Now, you can't do that very easily in a classroom, obviously, because there's a lot, well, I do it in a classroom, but you clearly can't do it with each and every student on an individualized basis. That's one of the problems with classroom teaching. It's very difficult to do. I've done quite a bit of it, and I'm pretty good at it, and I can tell you it's very difficult. Much easier to teach a student one-on-one. And what I find, if you use the right kind of homework, exercises, and quizzes then to follow up to give the student feedback, that very often can be sure the student is on a path. And in fact, that's what we do in our foundation course you're going to be hearing a lot more about. We give a student a topic, we explain something to them, then we give them a bunch of homework exercises. Then once they've done it and they think they understand it, then they take a quiz. If they don't pass the quiz, they got to go back and work on it some more until they do pass the quiz. Don't ever assume that a student knows something just because you've told them. As a matter of fact, one of the big dangers in a classroom is lecturing. You lecture and you think the students understand because they're not asking questions, and many times they're not following, and that can be a tremendous disaster. In fact, I would say that's the number one problem for many math teachers is they're very good at lecturing, but they're not very good at communicating. And lecturing and communicating are two very different things. And without feedback from the student, you're probably not communicating. As I said earlier, quizzes can be good to give the student feedback and for you to make sure the student's following. Now, that's the pedagogy, is interactivity and self-pacing. The students are going to learn at their own pace. Some students learn faster than others, and some students have got to review something more than one time before they get it, and that's all okay. That's an individual student. Now, content is the big thing. This is today where we really, really have a problem with our modern math, and I mentioned it in the very first video and in the first chapter. Today, we tend to section our math into big sections and teach it as separate, independent things, and it really is the wrong way to do it. So I'm going to let you read about this in the book, but then I'm going to talk to you now about something and give you an example of what I'm talking about right here. This is what I teach any beginning student in what I call the foundation, the first two tiers of a 10-tier system. The table of contents takes 3 pages here, as you're going to see. And you can find that on our website. The very first thing that I believe that, now mind you, this is for students that have been through elementary math, and this is post-elementary. So I'm assuming that they pretty much know the number system and how to use the number system, at least in basic ways. The first thing I want to teach them to do is to use the first power tool of mathematics that they're going to be introduced to, which is the scientific calculator, and I use a particular one. I use the TI-30XA because I find that to be a particularly effective calculator. It's only about $10 and it's very, very easy to use, and that's what I use throughout the foundation course. So I pretty much insist that a student get this calculator if they don't already have it, and don't use a different brand even though it might do the job, because the keys will be placed differently, and so then you won't be able to follow what I'm doing, and you might get confused by some of the different functionalities of the calculator. So use the TI-30XA. Now I have a series of lessons, and each one of these is a video with exercises and with quizzes, and there's 16 of them. And if you learn these 16 things here, you're going to know what you need to do practical math. And is that everything that's on the calculator? No, it isn't. There's a lot of things on this calculator that you'll never use in practical math, and I don't teach them. For example, anymore we don't use logarithms like we once had to when we did manual calculations. We don't do hyperbolic trig functions, for example. And there's a lot of statistical functions on here that we'll never use in practical math, in everyday math. So these are the keys you need to learn. And it doesn't take a student very long to do it, and it really should be fun. They watch a video, they work along with me in the video, I show them things, I'll say, okay, how do you take the square root of 98? Well, you do it there it is. And what's the square root of that? Well, there that is. If you square it twice, you get back to where you were, and things like that. And I teach them how to use the keys. One of the things that this calculator has that's very nice is fraction, the ability to handle fractions. So if you're not very good at doing it manually, multiplying and dividing and adding fractions, you can use the calculator to do it. And indeed, that's what I do anyway, because it's just fast. And in fact, I do virtually all my arithmetic calculations with a calculator because it's so much faster than doing it manually. I can do it manually. I've taught it, after all, back before calculators came along. That's how we had to do it. But now the calculator has just changed all that. And that's one of the keys, by the way, to the fact that we can do all this so fast. Then I have a section on pre-algebra, and there are 10 lessons. And this really is more or less a review of arithmetic and things that I think they already know for the most part. But in case they don't, I'm going to teach it to them again. So think of this as a review. And there's essentially 10 lessons. In fact, one of them I call optional, but it's a very interesting one to use. Then we do algebra. Now, you're going to be kind of surprised to see this, but this algebra only has 10 lessons. In fact, I have 4 more optional lessons that sometimes we put in the foundation course for some people. But really, these 10 lessons are what you're going to need to do practical math, everyday practical math. Now, is this everything that's in an algebra course, a regular algebra course? Oh, of course not. But it's what you're going to need for practical math. And that's why we put it here, and that's all we do in this foundation. Then the real meat of the course is geometry, because what we're going to be teaching people in practical math is how long should something be? What kind of an angle should something be at? Or what's the area of something? Or what's the volume of something? These are the kind of things that technicians run into all the time in industry, whether it's hydraulics or mechanical power systems or rigging or electronics. These are the kind of things you have to do. And so this is geometry, and there are, in fact, 20 lessons. One of them is optional, so 19 lessons plus an optional one. And if you learn how to do everything that's in these 19 lessons, you're going to be able to do most what I call everyday practical problems. Now, there is a problem with geometry in algebra. The most important polygon that you have to deal with in mathematics is a three-sided polygon. It's called a triangle. And it's the only rigid polygon. It's the only one where the lengths of the sides determine the shape of the polygon, that is, determine the angles. And so what you need to be able to do is do anything to solve any kind of a triangle problem. If you're given enough information, you ought to be able to calculate remaining angles or sides and the area and the perimeter. And the problem is with algebra and geometry, you often just can't. That isn't enough to do it. You need an additional tool. You need something called trigonometry. And so I teach in the foundation the basic things you need to know from trig to solve any kind of a triangle problem. And that's all. Now, trigonometry is a much huger subject than this. I mean, there's much more to it. But this is what you need to learn in the beginning. So these are the topics that are covered in the foundation course that we teach. And this takes a student probably about 50 hours of their time to go through the course. It's self-paced. They do it at their own schedule. I ask students to probably spend anywhere from 30 minutes to an hour in one session, and to do one session a day, a maximum of 2 a day, and usually one's plenty, and then maybe 4 or 5 times a week. And so it takes about 3 months to go through it. Now let me contrast that with a typical high school curriculum. I went to a website that has a lot of references and praise, and it was called yourteacher.com. And the person that created this about 10 years ago says that he taught high school math at a very, very good private school, and he considers this the ideal curriculum for high school. And so I just copied it off of the website onto these Word document. And you can go to the website, yourteacher.com, and see this for yourself. And he starts out, he has a pre-algebra, and there are 171 lessons divided into numerous chapters. Now, to be fair about that, some of this surely is review. A lot of this would be covered, I would think. Some of this would be covered in elementary school, although a lot of it isn't. And then there are multiple chapters, and I'm not going to go through them all. I'm just showing them to you here. And it goes down through page 4, page 5, and it ends up with 171 down here at the end. Now, I would maintain that a tremendous amount of this shouldn't be presented to a beginner. It's way too early to start doing a lot of these things. If you had a student that was going to be a future professional mathematician, you might argue that you should do this. But even then, I would take issue with that. I think you need to learn math in a tiered way. But this is a pretty demanding course. Now, how long is it supposed to take a student to do this? I don't know. It's 171 lessons. You tell me. I guess about a year to go through it. I'm guessing. I don't know what they advocate. But that fills up the first 5 pages. Then the second course is algebra, Algebra 1, and there's 116 lessons. And again, you can go to their website and view them in detail, but away they go. And I must just tell you, I think a lot of this is way, way premature for a beginning student. Now, clearly, a lot of teachers that teach this standard curriculum are going to disagree with me. So you're the audience here. You're the decision maker for your child, whether you're a teacher or a parent, and you've got to decide. But I would say that a tremendous amount of this is way premature for the first time through. Now you're going to ask me, well, do you cover these things in your program? And the answer is most of them, some of them, most of them, yes. And I'll tell you later in a future video how we do that, but not in the foundation course. And then after that, there's geometry, and that's 85 lessons. Not quite so many, but there's still a lot of things there. Obviously, some of this I cover in the foundation, but a lot of it I don't. I think it's premature. For example, we don't prove theorems at all in the foundation. I think that is way premature for that. And then after the geometry comes algebra 2, 95 lessons. And once again, there's a tremendous amount of stuff. And my view is, presumably, the kids are going through this in a linear way. And so this is probably the third year, but they're going through a lot of this for the first time. And I just think it's just the wrong way to do it. I mean, by the time you get to Algebra 2, perhaps I said enough about it. I hate to be so negative about something else. And by the way, I am not picking on yourteacher.com. That's probably an excellent program if you want to teach your student the standard curriculum. This is something you're probably going to go look at because he has a lot of rave reviews on his website. And I would say if a student is being forced through the standard curriculum by whatever school they're going to, whether it's a public school or a private school or a home school, this might be a good resource. I don't know. The other resource I mentioned in my book that I'll be talking about a little bit later is the Khan Academy. And Khan Academy has a bunch of free videos on almost all the same subjects. And I frankly can't recommend either one to you because they're the standard curriculum, which I think is wrong. And I don't know which one might be better. So that I'm not stating one way or the other. But in any event, that is the content portion. And by the way, that all added up to 16 pages is what we went through there. And that's what the standard curriculum is all about. Now, back to my discussion here, and I'm still in chapter 2. That was really my discussion on content as far as the foundation course goes. Now, there are then, after the foundation, there's things that you should be doing well beyond the foundation. And I'm going to talk about those in another video that will be coming a little later. This is what I want to say in this video about content, because if you're watching this video and you're trying to figure out what to do with your student, the place you should start is with the foundation. Now, in chapter 3, I talk about the power tools of mathematics. And quite frankly, this is a chapter you definitely need to read. There's a lot of teachers today that don't believe in using the power tools in teaching mathematics. As far as I'm concerned, they're just flat wrong. It's a huge mistake. And I think you need to read this chapter very carefully and see why I believe and why I believe you should believe that the power tools are important. The very first power tool that came along was the scientific calculator. That came along in, the first one was 1972. That was the Hewlett-Packard 35. And I talk about it in here a little bit. And I remember I was teaching engineering school when it came out. And it really upended, of course, their curriculum because all of a sudden they didn't need tables of logarithms and trig tables and slide rules and things. In 79 came the spreadsheet. Now, in one of the upper tiers, I began to use the spreadsheet, and I think if you're going to learn mathematics beyond the foundation, particularly if you're going to learn business mathematics, then you have to start using the spreadsheet. After you get through algebra and geometry and trig, and by the way, we go through it 3 times in the tiered program that we do, then you're going to get to calculus. And there's a tool that came out in 1988 that is absolutely remarkable. It's called Mathematica. It's tremendous. And it completely revolutionizes the way you do calculus and differential equations. And I use those in the upper tiers. And in 2009, Wolfram came out with Wolfram Alpha, which is Mathematica on the web for free, at least parts of it for free. And this is something you should know about, and you should be using it then in your training. Now, there are interludes that come along in this book. There are 6 of them, and in fact, I'll make a special video on just the interludes, but the interludes are also included on your CD-ROM because each interlude then has a video that goes with it that's on our website, but I'll put it on the CD-ROM as well. So you can get the interludes there. In chapter 4, I talk about mathematics education resources, And I will be talking to you in the next video about Dr. Simmons' book, which we use in the upper tiers, and comparing that to the standard curriculum. The Khan Academy I mentioned earlier is something you should know about. That is a wonderful, fantastic collection of free videos. The mathematics, there's over 1,000 math videos, and as far as I can tell, they follow the standard curriculum, much like the other one I talked about did. And so you might want to look at that if you're putting a student through the standard curriculum. It doesn't do what I do or what the foundation does at all, so it's not a competition to that. It's a very different thing. Wikipedia is a marvelous source for mathematics. I'm amazed at how much information is there. And then I mentioned the fact that we have the Dr. Dell 10-tier program, which is a work in progress, but the first 2 tiers are done and they're ready right now. And that's where I believe everybody should begin. So this has been a long video and audio, and I'm going to sign off, and we'll have a couple more to come then. So this is Dr. Dell. I will see you on the next video. Bye-bye.